How's it going, guys? Today, what I want to do is I want to go over the Module 1 test and preparation for the final that's coming up. So let's go ahead and get to it. For number 1 on the Module 1 test, we're asking you to identify the domain, range, and end behavior, and we're going to mark all that apply. So remember, our domain is going to be all possible x values on the graph. So we see our furthest left, our smallest x value, is on that line right there, and our greatest x value is on this line over here, and it's a continuous function in between those lines, and the endpoints are filled in. So we hit every single point at the lines and in between it. So our domain will be from -4 to -1. For our range, let's do that in red. Our range will go from our lowest y point right there and our greatest y point over here. Remember, our range is every single possible y value on the graph. And same thing as the domain, the graph is continuous in between those two red lines, and it's also filled in at those two lines. So the range, the red lines are actually part of the range as well. So our range will go from -2 to +2. And then for our end behavior, for us to have an end behavior, we need to have our graph going on to infinity to the left and to the right, or we need our domain to be going to infinity or negative infinity. It has to be going to one of those two. And our domain here is only from -4 to -1, and we're not actually going to infinity or negative infinity, so we don't actually have any end behaviors for this graph. So we have no end behavior. So that's our 3 answers. Let's go ahead and mark them off. So we have C, no end behavior. Our range is from -2 to 2. That's D. And lastly, our domain is from -4 to -1, or F. Let's go on to number 2. This one's hard to read, but what it's asking is which graph has a domain of X such that X is greater than negative infinity, and X is less than positive infinity. And it's also asking for a range such that Y is less than or equal to 7. So that's what it's asking for. Which one of these graphs has a domain of X that's greater than negative infinity and less than positive infinity? Or in other words, we want our range to be, our domain to be all real numbers, and we want our range to be every y value less than or equal to 7. So let's go ahead and look at our answer choices and see what we get. For A, we see our domain is all real numbers, so that's okay, and our range is also all real numbers. That's not what we want, so we can go ahead and mark off A. For B, that's our parent function quadratic. And our domain, our domain for that is all real numbers, so that's okay. But our range for this one is greater than or equal to 0. That's not what we want, so we can mark that off as well. For C, same thing, our domain is all real numbers, that's okay. But our range here is y is greater than or equal to what looks like -4. That's not what we want either, so let's go ahead and mark that off. And then for D, our domain is still all real numbers. That's perfect. Our range for this one is y is less than or equal to +7. That's what we want. So in this case, our answer is D. That's exactly what we want. A graph that has a domain of all real numbers and has a range that's less than or equal to 7. All right, let's go on to number 3. For number 3, we were asking which interval is the function increasing. So let's go ahead and mark where our function is increasing. And remember, for a function to be increasing, that means as you read the graph from left to right, the y values are increasing. So for this function here, the intervals that's increasing on will be from the arrow down there up to this turning point up here, and also from this turning point here. And it looks like it's going on forever. So let's go ahead and just lock these in place. Okay, and now let's go through every answer choice and see which one makes sense. For A, we're told from 1 to 2. So we want from here to 2 over here. And it looks like everything in between those points and at that point is increasing. So our answer choice A does make sense. But let's look at B, C, and D as well. So let's go ahead and just erase this over here. For B, we're asking from -2 to +2. So from here up to +2 here. And on this interval here, it looks like we have increasing portions and decreasing portions. That's not what we want. We want just increasing. So we can mark off B. For C, we're saying from 0 to 2. So from this interval here, from the y-axis to our point 2. It looks like we're half the interval is decreasing, half the interval is increasing. That's not what we want. We want just when the interval is increasing. So let's go ahead and mark off C as well. And last, we have D, which is from -2 to +0. And like the last answer choice, it looks like we're half increasing, half decreasing. And what we want is just increasing. So that means D is not correct. Let's go ahead and redraw our lines for A, which was from 1 to 2. This interval here up to here. And on that interval there, we're fully increasing. And this is for answer choice A. So that means our answer for 3 is A. All right, for number 4, we're asking over what interval is the function negative. For a function to be negative, that means we want everything below the x-axis. So let's go ahead and just mark our portions of the graph that's below the x-axis. So that'll be from this arrow here up to here, and on this portion here. And like before, we're going to lock this in place. And let's go ahead and look at our answer choices. For A, we have -1 to 1. So we're saying from here, from this line here, up to 1. And it looks like this interval right here is above the line. It's not in blue, so that's not what we want. So we can mark off A, because we want everything on that interval to be below the x-axis. So we can mark that off. For B, we want from -1 to +2. So from this line over here to +2, which is over here. And it looks like we have this line over here, which is still above the x-axis. That's part of the function in between the intervals that we have on that answer choice. That's not what we want. We want everything to be negative or below the x-axis. So we can go ahead and mark off B as well. C, we're saying from 0 to 2. Erase that. So from 0 to 2, we want everything in between these two lines to be below the x-axis or to be in blue. And in this case, everything in between those two lines is indeed in blue and below the x-axis. So C could be correct. Let's go ahead and look at D as well. For D, we want everything in between -2. We want that interval of -2 to 0 to be in blue or below the x-axis. From -2 to 0 will be between these two green lines. And it looks like everything in between those green lines is actually positive. It's above the x-axis. So D is the exact opposite of what we want. So our answer choice is C. Let's go ahead and just mark our lines again so you can see it, what the answer is. It's 0 to 2. And we see everything in between those two lines that I drew, which is from 0 to 2, is in blue and below the x-axis. So in this case, 4 is C. Okay, number 5, we're going to write the transformation rule for the following function. It's a little hard to see, so let's go ahead and rewrite the function. So in this problem here, our function is g of x equals 2 times f of 3x minus 5 minus 4. And remember, our transformation rule will always be bx plus h, comma, ay plus k. And our standard form for the function is g of x equals a f of 1 over b x minus h minus, plus k. This is our standard form of the, or sorry, not our standard form, but our vertex form of a function. So we're going to look at our function that they gave us, our g of x, and we're going to make our own transformation rule and see which answer choice it is. So before we do that, we need to figure out what our a, b, h, and k are. So from our g of x, we can see our a is 2. Our b, remember, it's 1 over b. So we want 3 to equal 1 over b. And if we solve this out, we get b to be 1 over 3. Our h is what's in here. Remember, the vertex form is x minus 8. So in this case, our h is 5. And lastly, our k is what's out here, which is -4. So we have our a, which is 2, our b, which we said is 1/3, our h is 5, and our k is -4. So let's go ahead and put this into our transformation rule. So we get b, which is 1/3, multiplied by x, plus our h is 5, so plus 5, comma a, which is 2, multiplied with y, plus our k is -4. And that's what we get for our transformation rule. So our answer for this problem here is B. Since that is the same thing, it's kind of hard to see, but it does say 1/3 x plus 5, comma 2y minus 4. And that's what our answer is. So our transformation rule is for our g of x. Okay, for 6, we're asking how many zeros does the function have. Remember, our zeros is our x-intercept, our roots. They mean the same. All three of those things mean the same thing. So we see we have one x-intercept here and one x-intercept here. So we know our answer is 2. We have 2 x-intercept or 2 zeros. What is the minimum value of the function? We're talking about the value of the function. That means our y value, our f of x, or our y value. So we want to know what our smallest y value of the function is. In this case, it'll be this point right here. That's our global minimum, our absolute minimum. That's what we kind of just learned in module 6. So in this case, our minimum value of the whole function, or our global minimum, is -1, or a. The y value of it is -1. Now we have some matching. So g of x equals negative f of x. Let me go ahead and rewrite this. It's kind of hard to see. This should say g of x equals negative f of x. In this case here, we're reflecting over the x-axis, so this will be b. For this one right here, it's still kind of hard to see. It's saying g of x equals f of negative x. So we're multiplying our x's by -1. So we're making our x's from positive to negative, and if we're flipping our x's from positive to negative, that means we're going over the y-axis. So in this case here, this will be a. And the same thing for g of x equals negative f of x. F of x is kind of the same as our y values. And if we're making our y from positive to negative, that means we're flipping them over the x-axis. So that's why a goes b and a. For 9, we're doing the same thing, the matching. So the first one says g of x equals 4 times f of x. If it's outside the f of x, that means we're having a vertical stretch, and we're having a vertical stretch by a factor of 4. So our a value in this case is 4. G of x says f of 4x. It's inside of the parentheses, so it's 1 over b. So our b in this case is 1/4, and it's going to be a horizontal compression by 1/4. G of x equals 0.25. 0.25 is the same thing as 1/4. It's outside of the parentheses. It's affecting the y directly. So that means it's going to be a vertical compression by 1/4, or C. G of x equals f of 0.25x. 0.25x is the same thing as 1/4. 1/4 is equal to 1 over b. So in this case, our b is 4. So we have a horizontal stretch by 4. Number 10, we have some more matching. We have g of x equals f of x plus 4. That's not inside the parentheses, so we're affecting our y directly. So it's going to be a vertical translation up by 4. G of x, this says g of x equals f of x plus 4. It's inside, the plus 4 is inside the parentheses. So this tells me it's going to be a horizontal translation to the right, to the left by 4. That's because it's f of x minus 4. So our h in this case is negative 4. So we're translating to the left by 4. G of x equals f of x minus 4 is the third one. Our k in this case is negative 4. So that means we're translating down by 4. So A. And last, we have g of x equals f of x minus 4. Remember, it's in the form x minus h. So our h value in this case is 4. So it's a horizontal translation to the right by 4, or C. What is the maximum value of the function? Like we said before, we want our maximum value. That's our global maximum, or absolute maximum. So we want the biggest x value, the biggest y value of the whole function. In that case, it'll be this point right here, which is at 6. So 11 will be B. Y equals 6. Our maximum value of the function is 6. All right, for 12, we see our parent function and the transform function. What is the equation of the transform function? So first thing I'm going to do is I'm going to look at the vertexes, which is right here and right over here. So we go from 0, 0 to, it looks like negative 4, negative 2. So this tells me my h is negative 4 and my k is negative 2. So if I'm going to make my my transform function, my new equation of the transform function, that tells me my g of x is going to be f of x minus h, so x minus negative 4 or x plus 4, and plus negative 2 or minus 2. So in this case, our answer choice will be C. 13, what is the restricted domain? Our restricted domain here is basically asking us what our domain is, and we see we go from this point here to this point here, which goes from 1 to 7. So our restricted domain is going to be A. Our domain for this problem is from 1 to 7, so our restricted domain is the same thing, 1 to 7. Okay. 14, it's kind of hard to see, but it's saying a red velvet rope hangs between two stanchions and forms a curve that can be modeled by a parabola. In the illustration shown, the unit of measurement for both axes is feet, and the vertex of the curve is point C. We need to find a quadratic function that models the rope and state the function's domain. It looks like we're only going to be solving for the function's equation. So for this one, we have our vertex form right there. And remember, to solve this, what we need is our h and k. We need our h, our k, and we need our a. And to solve for our a, we need to use our vertex and one extra point. So we see our vertex right here is at C, which is 4, 3.5. So our h is 4, our k is 3.5. So what we're going to do is we're going to put in our h and our k into our vertex form of the our vertex form of the function, and we're also going to plug in another x and y points. I'm going to use 1, 4, our point A, since 1 and 4 is smaller than 7, 4. And I think it'll be a little easier. So I'm going to put this into our equation. So our g of x in this case is going to be 4. We get that from our point. That will equal our a value, which is what we're solving for, our x, which is our 1, minus our h value, our h is 4, all of that squared, plus our k, and our k is 3.5. So now I'm going to solve for our a value. So I'm going to minus 3.5 to both sides. 4 minus 3.5 is 0.5. That equals A. 1 minus 4 is negative 3. All of that squared. That A looks like a 9, but it should be an A. So we have 0.5, which is just 1/2. That equals A times negative 3 squared, which is 9. So now I'm going to multiply by 1 over 9 on both sides to get rid of that 9 and get A by itself. So these 9s cancel, and we get 1 over 18 equals A. So our function's graph, our transform function is going to be g of x equals our A, which is 1 over 18, multiplied by x minus h. Our h we said is 4, all that squared, plus our k, which is 3.5. So that's what our function is. And let's go ahead and look at the answer choices and see which one aligns with that. In this case, it's B. It's hard to see, but it does say g of x equals 1 over 18, x minus 4 squared plus 35. 15, is the function even, odd, or neither? In this case, it's going to be odd. And that's what our answer choice is. 16, match the domain and range. So our domain here, we can see we're going on forever to the left and to the right. So we know our domain is all real numbers, or in other words, it'll be negative infinity to positive infinity. And it looks like that's going to be our answer choice, E over here. So our domain is E. For our range is going to be our lowest possible y value to our greatest. Since this is a continuous function, we can say that. And we're including, and our lowest possible y value is at negative 4. So we're going to go from negative 4, and we're including it since that is a full point. And it looks like we're going up forever. So we're going from negative 4 to positive infinity. We can't put a bracket around infinity. So that's what our range will be. So our range goes from negative 4 to positive infinity, which looks like it's our answer choice D. And D is different than C, since C has a soft parentheses next to the negative 4, and negative 4 is actually part of the graph, so we have to include it with the range. All right, and for our last problem, which is number 17, which is not a transformation of the function below, let's go ahead and just mark what all our transformations are. That 8 tells me we have a vertical stretch by 8. So that's one transformation. That 9 tells me we have a horizontal compression by 1 over 8. Since our b value in this case is 1 over 9, sorry, not 1 over 8. So our b value is 1 over 9, so we have a horizontal compression by a factor of 1 over 9. And then we have x minus 7, so that tells me we have a horizontal translation to the right by 7. And that should be an arrow. We have a horizontal translation to the right by 7. And lastly, we have that plus 5 outside. That's going to be a vertical translation up by 5. So let's go ahead and look at our answer choices and see which one is not a translation, or sorry, not a transformation. A says a horizontal translation left by 7. That looks promising because our graph has a horizontal translation to the right by 7. B says vertical stretch by a factor of 8. We said that. So that is a transformation, so we can mark that off. For C, we're saying a vertical translation up by 5. That's part of our new function. That's one of our transformations, so we can mark that off as well. And last, for number D, or letter D, it says a horizontal compression by a factor of 1/9. That is a transformation, so we can mark that off. So A is our answer choice for number 17.